So sometimes you might get a function, more complicated function, embedded inside a quadratic function. For example, you might get something like this. So if we have something like this, 5x squared plus 5 squared plus 5 bracket x squared plus 5 plus 3. Now what you got to notice here is that is in the form of a quadratic function where x is equal to negative b plus or minus square root of b squared minus 4ac over 2a, right? I'm going to stop saying this, but it's a good idea for you to continuously say it until it just rolls off your tongue, right? Like I said, you should have nightmares or dreams about this, right? So that's your quadratic function, but this x is not that x. This x is whatever is being squared, okay? And this x is when it comes to expressions where there is some confusion, where it does confuse people. So what you should think about it is, again, this is not an x, it's whatever is being squared, which is in the form of the quadratic equation. So the way you should think about it is, this guy here is representing our x here. So this is our box. This is our box, which is in the form of a quadratic equation, and our box, not the x, is equal to the quadratic formula, right? That way, what you can do is use the quadratic formula to solve for this equation, right? Or to factor, this is not an equation because there's no equal sign there, to factor this expression, right? And at the end, what you're going to end up having, if this is factorable, you're going to have x squared plus 5 is equal to this, right? So the way you should think about this box, x squared plus 5, replaces the box. Now, you don't want to sit there and write down x squared plus 5 is equal to your a, b's, and c's in the quadratic formula, right? So b here is 5, so this would be negative 5 plus or minus the square root of 5 squared minus 4. Our a is 2, and our b and our c is 3, divided by 2 times a, which is 2 times 2, right? So that's what the quadratic equation gives us, right? But over here, you don't want to constantly write down x squared plus 5, right? What you want to write down is just one letter, one expression, one term, so that way you don't have to worry about it. And so the way we do this is, what we do is use the let statement. So what you can say is, let w. So we're going to say let w equal x squared plus 5. And that gives us a certain amount of control to rewrite that function or that equation or that expression in the form of a quadratic equation that we can recognize instantaneously. So as soon as we say let w equal x squared plus 5, all of a sudden we're going to have w is equal to this. And our above equation turns into the quadratic formula, which is what we want, right? So it turns into, let's write this guy here. If we say w, let w equal x squared plus 5. So what this turns out to be is, right? Hopefully you can see that. So at the beginning here, the way we're going to do one in order, we're just sort of I'm trying to go through the explanation of, the mental process and why we do this, just to make life easier for us, right? So what we end up having here is going to be w is equal to, this guy simplified. So that's going to be negative 5 plus or minus 25. 4 times 2 is 8. 8 times 3 is 24. Minus 20 divided by 4. Right? 25 minus 24 is 1. So the square root of 1 is just going to be 1. So it's going to be negative 5 plus or minus 1 over 4. W is going to be negative 5 plus 1 is going to be negative 4 divided by 4 is going to be negative 1. And or, if you want to think about it, it's an or, but it's an inclusive or, okay? So it's this, or that, or both, okay? So negative 5 plus 1 was negative 4, divided by 4 is negative 1. Negative 5 minus 1 is negative 6 divided by 4 is negative 6 over 4, and that can be simplified into negative 3 over 2. So right now we have two answers, right? We have w is equal to negative 1, and we have w is equal to negative 3 over 2. Now we haven't finished solving this equation yet, because in this expression, if you're given that question to factor that question or to solve that question, what you need to do is, it would basically be solved, right? They wouldn't give it to you to say factor. What we're working towards is equal to 0, and we're trying to solve this equation, right? So if you got w is equal to negative 1, you're going to have to go back to the original let statement when you began this expression, began solving this equation. W is equal to x squared plus 5. So what you end up having is, right down here, you're going to substitute w is equal to x squared plus 5 for w, and then solve for x, because x is what you're looking for. So what we had was, we let w equal x squared plus 5, and we solved for this, and we got w is equal to negative 1, and w is equal to negative 3 over 2, right? I'm going to write these a little bit bigger so they come out nicer. So what we end up doing is substituting this for w. So what we're going to end up having is x squared plus 5 is equal to negative 1, and x squared plus 5 is equal to negative 3 over 2. Okay. Now, right now, you're going to have to solve for x squared. So what you're going to do is move the 5 over. So you're going to have x squared is equal to negative 6, square root both sides, and x squared is going to be, or x is going to be square root of negative 6, right? And there, you can't take the square root of a negative number, so this one doesn't give you an answer. There is no solution for x here. Over here, we're going to have the same problem. If you don't like fractions, get rid of your fractions right away by multiplying by 2, right? You can multiply the whole equation by 2, so you're going to have 2x squared plus 10 is equal to negative 3. And again, we've talked a lot about this in series 3a, and you should know how to do this if you don't already. And then grab the 10 over, so you're going to have 2x squared is equal to negative 13, divide by 2, divide by 2. So x squared is equal to negative 13 over 2. And then if you take the square root of both sides, you're going to have x is equal to square root of negative 13 over 2. And again, this one is not going to give you a solution, okay? So the basic format is, if you get something that looks a little confusing, what you can do is use the let statements to, to make substitutions into the, the expression or the function or the equation that they've given you, for you to be able to put it in a form that you can recognize, that you can use the quadratic formula in, okay? Let's do one where, we did as a complex trinomial factoring, and use the let statement and use the quadratic formula just to prove to ourselves that we're going to get the same answers, okay?